Hey guys, welcome to the channel vibgyoroftalents. So in today's video, we'll be doing all the problems in this exercise 8.1. So follow up with me. Let's get started by doing this problem. So this is the first question that has been given to us in this exercise 8.1. So let's just read that. So in this question, we have been given that in triangle ABC, which is right angled at B, AB is equal to 24 centimeters, BC is equal to 7 centimeters, and we have to determine the values of sine A cos A, which is our first bit, and then we have to also find out the values of sine C and cos C. So these types of problems we have already seen how to do in the previous video, so it's going to be super easy now to solve it. But first of all, if you remember in the previous video, the first step that I have said you is to actually draw a triangle, a rough triangle, which would be helpful for us to determine the values very easily. So if we first draw a right triangle in this chapter for trigonometry, and then let's write the values that has been given to us in the question, then after that we'll be getting some values. So if we keep updating our triangle according to the values that we have been getting, so it's going to become very simple to find out the solution at last. So let's solve this problem in the same approach. So first of all, let's draw a right triangle. So I'm going to draw my right triangle somewhere over here. So this is my right triangle. Alright, so they have said us that the right angle is at B. So I'm going to consider this as my right angle. So this is my B. Alright, so this would be A. I would take this as A and this is as C. Okay, cool. Now from the question itself, we have known the values of AB and BC. So let's just quickly write up the values that have been given to us. So from the question itself, we have known the values of AB and BC. So let's just quickly substitute the values of AB and BC. So the value of AB is given as 24. So I have write it in the AB place, and the BC value would be 7. Nothing to do, just we have wrote what has been given to us. So if you look at this triangle, now if we find the other side, which is AC, then we'll be able to simply solve and get the trigonometric ratios, all the trigonometric ratios. So how to find this side AC? We can use our Pythagoras theorem to solve this problem. Alright, so what does the Pythagoras theorem say? The Pythagoras theorem actually says that AB square plus BC square is equal to AC square. Right, we have known it from our previous classes itself. Alright, so we have known the value of AB and BC over here. So let's just substitute in order to get the hypotenuse, which is AC. So AB is 24. So 24 square plus the value of BC is 7. So 7 square would be equal to AC square, right? Alright, so I've said you to learn the values of all the squares till 25 and all the cubes till 15. So it's going to be easy to solve all these types of problems super quick. So if you might have learned them, then you would quickly shout out the answer of 24 square, which is 576, and the square of 7 is 49. So 576 plus 49 would be equal to AC square. Alright, so what is 576 plus 49? Simple math, it's just 625 would be equal to our AC square. Alright, now in order to find the value of AC, if we take root on both sides, then we can find the value of AC. So AC is equal to root of 625 because the square and root get cancelled in the case of AC, and then we are going to be left with AC is equal to root of 625. So we know that root of 625 is equal to 25, and you can also tell that if you learn the square till 25 itself, so AC will be equal to 25 centimeters, not centimeters. We don't know it's there in which value. So AC will be equal to 25. So let's just write that in our triangle. So AC is 25. Cool. So now as we got the values of all the three sides, it's going to be very easy to actually find out sine A, cos A and sine C, cos C. So first of all, let's write it as first bit and then solve it. Alright. So what is sine A? What is the value of sine theta? So if you remember, the value of sine theta is opposite side by hypotenuse. the SOH, if you remember. Alright, so what is the opposite side that we have here? We have to find out the opposite side for angle A, because first we have to find angle A in this first bit. So opposite side to angle A will be BC. So what is it? It's 7 centimeters. So sine A would be equal to the opposite side, which is 7 centimeters. And what is the hypotenuse? It's 25. So 7 by 25. Alright. And then next we have to find cos A. So cos A would be equal to 24 by 25. The simple reason is that what is cos theta? Cos theta is nothing but the adjacent side by hypotenuse. So the adjacent side to A is 24, angle A is 24, and then the hypotenuse is 25. So it's going to become 24 by 25. Alright, we are done with the first bit. So in the second bit, let's solve the second bit right now. So in the second bit, they asked us the value of sine C and cos C. So then we have to consider this particular angle. So the angle opposite to the angle C is 24. So then sine C would be equal to opposite side by hypotenuse. So what is the side opposite to angle C? It's 24. So sine C would be equal to 24 by 25, and then cos C value would be equal to, so let's just find out. So cos theta's value is nothing but adjacent side by the hypotenuse. So what is the adjacent side over here? You see the adjacent side to angle C is 7. So it's going to become 7 by 25. Alright. So that was given in the question that we have to find sine A, cos A, sine C, and cos C. So yeah, we have found out all of them. So let us have a look at the next question that we have here. So in this, we have to look at the picture 8.13 and just find tan P and cot R. We should find tan P minus cot R. First of all, we should find the values of tan P and cot R. Then we can find out the values. So in this question also is similar to the previous question, but in here they made it more simpler for us. No need to even draw the diagram. The diagram has already been given to us from the question itself. So this is the diagram for us, and we have been given the value of PQ and PR. So again, if we know the value of QR that we have here, then we'll be able to solve the problem and get the trigonometric ratios tan P and cot R. For this also, we can use the Pythagoras theorem that we used in the previous problem also. So the same would be applicable over here. So as you see, PQ, so the hypotenuse here is PR. So it's going to be PQ square plus QR square is equal to PR square. Alright. So in here also we know the value of PQ. So it's 12 centimeters. So it's going to be 12 square plus QR is unknown. So let it be QR. We are not going to change it now, and let's substitute the value of PR. What is it? 13. So it's going to be 13 square. Alright, so 12 square is 144, and then QR square as it is, no change to it right now, and then 13 square is 169. So in order to get the value of QR, if we send this 144 to the right hand side, we are going to get the value of QR square. Let's just do that. Thus QR square would be equal to 169, and it's going to become minus 144 because it was plus in the left hand side. When it comes to the right hand side, it's going to become minus. So 169 minus 144. So then QR square would be equal to 25. Simple math, 169 minus 144 is 25. So then we have to find the value of QR. So QR would be the root of 25, which is 5 centimeters itself. So, but let's write all the steps so that we are going to understand it perfectly. So QR would be equal to 5 centimeters. So let's update our triangle 2. Alright. And sorry guys, my handwriting is not so good because I'm not experienced on this actually. So I promise that I'm going to improve day by day. But please bear with me till then. Alright, now we have to find the value of tan P. Right, so I'm going to just write tan P is equal to So where do we find the angle P? So the angle P is just hiding over here under this blue thingy, but let's just mark it tan P. Alright, so what is the value of tan theta? We know that tan theta, or the code I've said in previous video, is TOA. So tan theta would be equal to the opposite side by the adjacent side. So what is the opposite side of angle P? It's QR. So it would be 5 by, what is the adjacent side? So I've said you that hypotenuse wouldn't change. So what is the adjacent side? The other adjacent side for P, it's PQ, so it's going to be 12 centimeters. So tan P would be 5 by 12, and then we have to find cot R. So cot R, actually if they would give us cot P, then we could simply find it out by just doing the reciprocal of tan P, because cot is just the reciprocal of tan. But actually now we are being asked the cot ratio of angle R. So let's just find the angle R. So this is our angle R here. So the value of cot, the trigonometric ratio of cot theta is nothing but the adjacent side divided by the opposite side. So what is the adjacent side for angle R? It's QR itself. So it's going to be 5. And what is the adjacent side? The adjacent side is 12 centimeters. So it's going to be 5 by 12 again. Alright. So now they also asked us to subtract tan P minus cot R. So it's going to be 5 by 12 minus 5 by 12. Because we have the values of both tan P and cot R. So finally the answer would be 0. So we can say that tan P minus cot R will be equal to 0. Simple question, that's it. So this is the third question that we have in our exercise 8.1. So let's just read it. So the question says that if sine A is equal to 3 by 4, then calculate cos A and tan A. So the first step that we are going to do always, just draw a right angle triangle. That's what I'm doing right now. So this would be my right angle triangle, and then let's also name it as ABC. Alright, so we have been given that sine A is equal to 3 by 4. So as we are considering 90 degrees at this, so this is going to be our angle A. So this is going to be according to that angle itself, because in the question itself they have been given about sine A. Alright, so they said that sine A is equal to 3 by 4. So they didn't give any information actually, they didn't give sides. So how do we find out? So don't at all get worried. So they have given one of the ratio. So if one of the ratios is given to us in this trigonometric ratios triangle, the right angle triangle, then we can actually find all other trigonometric ratios. Alright, so how to do that? So you might be knowing from SOH, what is that? Sine theta is equal to opposite side by hypotenuse. The formula would be sine theta is equal to opposite side by hypotenuse. So opposite side by hypotenuse is equal to 3 by 4. So opposite side, what do we know? We know that the opposite side will be equal to 3 and the hypotenuse will be equal to 4. So we got it from our sine A itself. So sine A was equal to 3 by 4. So opposite side is equal to 3 and hypotenuse is equal to 3, because sine theta is equal to opposite side by hypotenuse. I repeat it because it's important to understand that. So let's substitute our values according to what we have got. So the opposite side to angle A would be BC. So this would be 3. The length of BC would be 3. And we know the hypotenuse is 4. So AC would be 4. Alright. And now we have to find out the values of cos A and tan A. How to do that? It's also similar to the previous questions that we have seen. So in here also we can find the side AB by using the Pythagoras theorem. Then we can find out all the trigonometric ratios. Alright. So the same way, so it's gonna be, what is the Pythagoras theorem? The Pythagoras theorem is AB square plus BC square is gonna be equal to the AC square. Alright. So we have to find the value of AB itself. So AB would be as it is, no change for that now. So AB square plus the BC square is 3. So 3 square will be equal to AC square. We know the value of AC itself. So 4 square. Alright. So no change to AB right now. AB square plus 3 square will be 9 and 4 square will be 16. So AB would be equal to AB square would be equal to 16 minus 9. I've said you what's the reason for taking this 9 from the left hand side to the right hand side and getting the signs converted. And then AB square will be equal to 16 minus 9, simple math, it's 7. So what will be the value of AB now? If we take root on both the sides, then the value of AB would be equal to root 7. So sometimes we'll be getting the values in roots also. So don't get tense that you might be doing it wrong. It might be completely correct. Don't at all get tense. So in the question, if you look at, we have to find the values of cos A and tan A. So as we have found out the other value of AB, the other side in this triangle, let's just update our triangle according to that. So the value of AB would be root 7. So now we have got all the sides in the triangle, and simply we can find out the ratios. So first we have to find out the value of, so we have to find the value of cos A first. So if you remember, what is the value of cos theta? If you remember the code that I have said you, the code is CAH. You might be remembering now. So cos theta will be equal to adjacent side by hypotenuse. So what is the adjacent side for this angle A? It is going to be root 7 and not 4, because 4 would be the hypotenuse as it is slanting. Remember that if it is in that situation, remember that the slanting side will be 4, which is the hypotenuse. You shouldn't take that. The other adjacent side you should be taking, which is root 7. So cos A would be root 7, and the hypotenuse, as I've said you right now, is 4. So cos A will be root 7 by 4. So we have got the value of cos A. And then we have to find out the value of tan A now. So let's write the value of tan A. So if you remember, for tan A, the code is TOA, which is tan theta is equal to opposite side by adjacent side. So what is the opposite side for A? It is 3. So 3. And what is the adjacent side? You shouldn't take this hypotenuse, so it's going to be root 7. So it's going to be 3 by root 7. So that is it. They asked this cos A value, they asked this tan A value, we have got both. But yeah, if you actually want to further simplify the value of tan A, you can do it because there is a root in the denominator. You can actually divide and multiply with the same number, so the value wouldn't change and there would be no root in the denominator. So let's just do that. Let's just simplify it. So it is going to become 3 root 7, 3 divided by root 7 into root 7 by root 7. So the value would be 3 root 7, and root 7 whole square is nothing but 7. So tan theta, you can actually directly write it as 3 root 7 by 7. It's just a simplified way. That's it. Cos A and tan A successfully got the values. Let us have a look at this question that has been given to us. So it is given that 15 cot A is equal to 8, and we have to find the values of sin A and sec A. So this is similar to the previous problem that we did. There also we have been given one of the trigonometric ratios and we had to find the other. So in here too we have been given that 15 cot A is equal to 8, which is one of the trigonometric ratios, and we have to find out the other two trigonometric ratios, which are sin A and sec A. So actually they have not directly given us the trigonometric ratio as it is. So they gave us as 15 cot A is equal to 8. So we can just simplify it very easily and we can write it as cot A is equal to 8 by 15, right? So if I take this 15 from over here to here and bring it down, so it's going to be 8 by 15. Because the 15 was on left hand side, I just took it to the right hand side. It was multiplying with cot A. So after coming to the right hand side, it is just being divided. So as we have got two sides in the triangle, let's just quickly draw a triangle. It is the best way to find the solutions of problems such as this. So let's draw a triangle. Okay, so let's just consider this as triangle, and this is gonna be 90 degrees. And then they gave us that cot A is equal to 8 by 15. To actually know the sides also, we have to be knowing the trigonometric ratio of cot A itself. So in the previous video, I said you have to remember the values of trigonometric ratios very easily using the codes. So if you remember, the value of cot theta is equal to 1 by tan theta. So it is the reciprocal of tan theta. So what was the code of tan theta? It was TOA. So tan theta was equal to opposite side by adjacent side. So as it is the reciprocal of tan theta, so cot theta would be equal to adjacent side by the opposite side. So this 8 is gonna be our adjacent side. I'm gonna write it as AS. So 15 is gonna be our opposite side. Alright. So it's gonna depend which side we are gonna consider according to our triangle. So for me in here, I'm taking this as A, this as B, alright, and this as C. Now, according to the question, we are given that the adjacent side would be 8. So if we consider this as angle A, so what is the adjacent side to this angle A? It would be this particular side, because this side is going to be the hypotenuse, so we are not going to consider that. So the other adjacent side to angle A would be this, so it's going to be 8. So alright, so the opposite side would be BC. Okay, now as we got our two sides AB and BC, so if we are going to get the other side which is AC, then we'll be able to know all the trigonometric ratios. So how to go about that? Just by using our Pythagoras theorem. So what does Pythagorean theorem say? Let's just write the formula first. So it's going to be AB square plus BC square would be equal to AC square. So this is going to be also dependent according to our triangle. So if we take this triangle like which we draw here as ABC, so it's going to be like this. According to our triangle, our Pythagoras theorem keeps changing. Alright. So the value of AB that we have here is 8. So let's just substitute that. So it's going to be 8 square. So let's just substitute the value of AB. So what is the value AB given here? So it's going to be 8. So 8 square. And the value of BC that has been given is 15. So it's going to be 15 square will be equal to AC square. Alright. Now we have known the values. We have learned the values of the square till 25. I assume that. So you have learned. So 8 square would be 64 and 15 square would be 225 would be equal to AC square. So 64 plus 25, simple math, it's going to be 289. So 289 is equal to AC square. So what would be the value of AC? Simple. AC will be equal to root of 289, and you might be knowing, if you have learned the square till 25, it's 17. So we have got the value of other side also, which is 17. So let's just update our triangle. So I'm going to write 17 over here. That's it. Now it will be just a cakewalk for us to find the other values. So in this question, we have been asked to find the value of sine A and sec A. So let's just find them now. First of all, we have to know the value of sine A, means the formula of sine A. So sine A, what is the value of, what is sine theta? What is the formula of sine theta? So sine theta will be equal to opposite side by the hypotenuse. So in here, angle A is right there. So what is the opposite side to that? It is BC. So BC, and what is our hypotenuse? It's AC. Alright. So sine A, what is the length of BC? So we have known the length of BC as 15. 15 divided by AC. So what is the length of AC? 17. So sine A would be equal to 15 by 17. And then we have to also find the other value, which is sec A or secant A. So if you remember the formula of secant A, it was 1 by cos theta, or the reciprocal of cos theta. The code for cos theta was CAH, if you remember, which is cos theta is equal to adjacent side by hypotenuse. So sec theta is the reciprocal of that. So it's going to be of the hypotenuse by adjacent side. So let's write it. Sec theta. Here we have sec A. So sec A will be equal to, what is the hypotenuse? It's AC for us. So AC by, and what is the adjacent side? It's going to be 8. So just AB. So we'll write it first as this step, and in the next step we can write the values. So AC's value will be equal to 17, and the value of AB is 8. So that is it. We have got. In the question, they have asked us to find the values of sine A and sec A, and yeah, we have got both the values of sine A and sec A. So that is it. We have got both the values, so we are done with the question. Let's move on to the next one. Okay, so let us have a look at this question number 5 that has been given to us in exercise 8.1. given that sec theta is equal to 13 by 12, and we have to calculate all the other trigonometric ratios. So this is a simple question that is similar to the previous question that we have done. So in here we have given that sec theta is equal to 13 by 12. So first of all, in order to do these types of questions about trigonometric ratios, we should be perfect with all the trigonometric ratios that we are having. So first of all, to get the sides, the two sides, let's write sec theta that has been given to us. So sec theta, let us write what has been given to us. We have been given that sec theta is equal to 13 by 12. So let us write it. Okay. So we know what is the value of sec theta. It is nothing but the reciprocal of cos theta. So first of all, you should be knowing the ratio or the formula of cos theta itself. So we know that cos theta's code is CAH, which is cos theta is equal to the adjacent side by the hypotenuse. So as it is the reciprocal, so sec theta would be equal to the hypotenuse divided by the adjacent side. 13 is going to be our hypotenuse. I'm going to write it as HYP, and this is going to be our 12 is going to be our adjacent side. So I'm going to write it as AS. Alright, so as we have got our two sides now, let's quickly draw a triangle, and then we can substitute what has been given to us. So this is a triangle done, and then this would be 90 degrees. So I'm making it as point B, A, and C. Alright, so the hypotenuse is 13. So this is going to be 13. And what is the adjacent side for theta? So first of all, we have to consider which angle is going to be our theta. So we can consider any angle. In here, let's consider B. So this is going to be theta. No, B is 90 degrees, so I'm taking C. So this C is going to be theta. Alright, so what is the adjacent side for this theta? It's BC. So BC's length would be 12. Okay, that's it. We are done with drawing a triangle. Now let us try to find out the other side. Then we are able to find out, then we are going to find out the other trigonometric ratios. Alright, so how do we find the other side that we don't have, the unknown side? So we are going to find it out using the Pythagoras theorem. So what does Pythagoras theorem say? It says that AB square plus BC square is equal to the AC square. Alright, so what is the length of AB? We don't know what is AB, so I'm going to just write it as AB square itself. No change there. And BC square, what is the value of BC? So it's going to be 12 whole square. And then we have known the value of AC also. What is AC? It's 13. So it's going to be 13 square. Alright, so AB square is going to be same because we don't know the value yet of this AB square. And then 12 square would be 144. And 13 square would be 169. So then AB square would be equal to 169 minus 144. So it's simple math to subtract it. And then AB square would be equal to 25. Same simple math. 169 minus 144 is 25. And then the length of AB would be equal to root 25, which is 5. So the length of AB is 5. So let us update a triangle. Now as the question follows, we have to find all the other trigonometric ratios. So let's start off with the first pair of trigonometric ratios. So first of all, the first trigonometric ratio is sine theta. So sine theta code is SOH, which means that sine theta is equal to the opposite side by hypotenuse. So we have considered angle C as theta. So the opposite side is 5. And then what is hypotenuse? It's 13. So sine theta is equal to 5 by 13. Let us move on to the next trigonometric ratio, which is cos theta. So we have just recalled what is cos theta before solving the question. So cos theta is CAH. The code is CAH. So what is going to be? Cos theta is equal to the adjacent side by the hypotenuse. So the adjacent side is BC. So we're going to write it as 12 by 13. So we have to find the next trigonometric ratio. So we are going to find tan theta. So tan theta will be equal to sin theta by cos theta, or we can actually say it as TOA. The code is TOA. So tan theta is equal to the opposite side by adjacent side. So what is the opposite side? It's 5. And what is the adjacent side? It's just 12. So yeah, we have got the first pair of the trigonometric ratios. Now it's going to be super simple to find out the second pair of, not actually pair, there are three, so group, let's call them group. So we have called the first three as one group and the second three as one group. So sin theta, cos theta and tan theta, remember them as one group, and remember sec theta, cosec theta and cot theta in the other group. I'm going to tell you what's the reason, and you will be noticing itself, because all the values of sine, cos and tan will be the reciprocal for the second group. So sine theta will be equal to 1 by cosec theta and cos theta will be equal to 1 by sec theta, tan theta is equal to 1 by cot theta. That's the reason we are going to call it as two different groups. So as we have found out the first group, it's going to be just the reciprocal of them in our second group. So then first comes cosec theta, cosec theta. So as I said you, it's just the reciprocal. So we are going to get cosec theta is equal to reciprocal of sin theta, which is 13 by 5, because sin theta is 5 by 13. The reciprocal would be 13 by 5, and then sec theta we have already got given in the question, so no need to find it out again. And you can actually check. So cos theta is the reciprocal of sec theta. So cos theta's value is 12 by 13 and sec theta is 13 by 12. So we are in the right direction, we are doing it perfectly, no doubt. And then sec theta I'm going to find, so cot theta. So cot theta is the reciprocal of tan theta. So tan theta was 5 by 12. So it's going to be 12 by 5. So that's it. We have found all the trigonometric ratios, all 6 trigonometric ratios. We have found out 5. One was already given in the question. It just made it simpler. That is it. Cool. We're done with this question. Let us have a look at this question that I have been given here. So if angle A and angle B are acute angles such that cos A is equal to cos B, then show that angle A is equal to angle B. So this is a proof. So proofs are kind of more difficult from the normal problems that we did before. So you should be a little careful while doing these types of problems, and I'm gonna give the step-by-step process on how to do these types of proofs. Alright, so let's get started. So let's start this question also with our obvious thing to do, the first step. So it's gonna be to draw the triangle, the rough diagram. Right, so this is going to be my triangle, and let's name it ABC, because in the triangle they have given that, in the question they have been given that angle A is equal to angle B. So I'm going to consider my triangle as ABC. So this is going to be the 90 degrees. So they said that angle A and angle B are acute angles. So this diagram which I drew right now, would it be correct? No, it wouldn't be correct. So you shouldn't draw a diagram like this, because in here the angle B is actually 90 degrees, but they said that angle A and angle B should be acute angles, means which is more than 0 degrees and less than 90 degrees. But here we are having a right angle and not an acute angle, so we have to be changing our triangle. Let's actually change the naming of a triangle so that it's going to be simpler rather than to draw another one. So I'm going to put this angle as A and put this angle as B, and I'm going to put this angle as C. Now it suits because this is an acute angle and angle B is also acute angle. Angle A and B are acute angles and C is going to be 90 degrees. So it satisfies this condition that A and B should be acute angles, right? Alright, so we have satisfied the condition. Now the next thing that have been given to us in the question is that cos A is equal to cos B. So if you remember the trigonometric ratios of cos theta, or actually the formula of cos theta, you are going to remember it if you actually remember the codes which I have said you in the previous video. So if you remember, the code for cos theta is CAH, which means that cos theta is equal to the adjacent side by the hypotenuse. So first of all, let's write that cos A is equal to cos B. So cos A is equal to cos B. Alright, and then they have also said that angle A and angle B are acute angles. So they have not given any other information rather than these two. So we have to find out all this stuff from these two things that has been given to us. So cos A and cos B. So I have said you the code which is CAH, which means that cos theta is equal to the adjacent side by the hypotenuse. So first of all, let's take the cos of angle A. So this is the angle A that we see here, and if you want to find the adjacent side for this angle A, it's going to be CA, right? We couldn't consider BA as it is the hypotenuse, so we are considering the other adjacent angle for A, adjacent side for this angle A, so it is CA. So let's just write that. So it's going to be CA by, and then what is the hypotenuse over there? So the hypotenuse is AB itself, so it's going to be AB. So CA by AB is our cos A. Now let us find out cos B. So what is the adjacent side for this angle B? It's CB that you see here, right? So let us write CB in here. So CB by, what is the hypotenuse that we have? So in here also the hypotenuse is same, so it's going to be AB. So CA by AB is equal to CB by AB. So that we have got from this thing, which is cos A is equal to the cos B. Alright, so next step we are going to cross multiply the stuff that has been given to us. So we'll be cross multiplying only one pair rather than the two pairs that we see here. So let's cross multiply these two, AB and CB. So we are actually going to switch the places of both of them. So it's going to be AC by, I have switched the places. So it's going to be AC by CB is equal to AB by AB, right? Alright, so we have known that AC by CB is equal to AB by AB. So AB by AB we could actually cancel it and we can write it as is equal to 1. Alright, so we have got AC by CB is equal to 1. So simply if you take this CB over here, we are going to get it as AC is equal to CB. Okay. So in here, these side AC and this side CB are equal. So if you remember the different types of triangles that we have learnt in the previous classes, among one of those type was the isosceles triangle. So when do we call a triangle isosceles? When two sides are equal and the other side is different. If all three sides are equal, we would call it equilateral, but as in here we have two sides equal, which is AC and CB, we are going to say that this triangle ACB is isosceles because AC and that CB are both equal. So triangle ACB is isosceles. So I've written it. Alright, so what is the sum of all the angles in a triangle? So we can say that angle A plus angle B plus angle C will be equal to 180 degrees. So how do we get that? It's from the angle sum property of triangles, and then one angle is already given to us, which is that 90 degrees. 90 degrees is already given to us, and angle B and angle A, let's write it as it is. So you will know why we are doing all this. And then so if I take this 90 from this side to this side, so we can say that angle A plus angle B will be equal to 90 degrees, right? So these two angles, they sum up to 90 degrees. So we have known something else from the isosceles triangles. What is that? So we know that as two sides are equal, there is going to be two angles which are going to be same in the triangle. So as one angle is already 90 degrees, so we know that angle C is equal to 90 degrees. Now we are left with angle A and angle B. So that we got it as the sum, we got it as 90 degrees. So we can consider these two angles to be equal. It will be equal because one angle is 90 degrees. So this is going to not be equal for any other angle. Because if we take any other angle as 90 degrees, then the sum would become 180 degrees. But in a triangle, the three sides should add up to 180 degrees, not two. The three angles should be equal to 180 degrees. But in here, we have one angle as 90 degrees. So it's going to be not equal to anything else. Only that angle will be 90 degrees. So we can say that this angle A and angle B are equal. How? So we can actually prove it also. You can take angle A plus angle B is equal to 90 degrees. So each are going to be 45 degrees. 45 degrees will be equal to angle A is equal to angle B. So I hope you understood. We have took many situations in here. So basically it's based that in a triangle one angle is 180, the sum of all the angles is 180 degrees. So as this is a isosceles triangle, two angles are going to be equal, and as one angle was already 90 degrees, the sum of the other two will be 180 degrees minus 90, so it is 90 itself. So angle A, those two angles sum will be equal to 90 degrees. So only those two angles can be equal, nothing else can be equal. And they are going to be equal to 45 degrees each. So angle A is equal to angle B, and their angle also, if you want to find out, it's going to be 45 degrees. That's it. This is a little complicated and a little twisted, but if you remember it, it is going to be super easy. That's it. We are done with the question, and at last we have proved that angle A is equal to angle B and the length is also going to be 45 degrees. That's it. Let us have a look at this question that has been given to us. It is the question number 7 of exercise 8.1. So let's just start it. So in here we have been given the value of cot theta as 7 by 8, and in here we have two bits, which is 1, we should evaluate 1 plus sine theta of 1 minus sine theta divided by 1 plus cos theta of 1 minus cos theta, and second bit is cot square theta. Okay, so let us have a look at how to do these types of questions. So first of all, we have been given that, so in the question we have been given that cot theta is equal to 7 by 8, right? So we know that cot theta is the reciprocal of tan theta. So what is the code for tan theta, which is TOA? So by that we'll be remembering that TOA will stand for tan theta is equal to the opposite side by the adjacent side. So cot theta is reciprocal of tan theta. So it is going to be cot theta is equal to the adjacent side by the opposite side. So we can say that 7, which is there here, is our adjacent side, and then 8 is our opposite side, right? Okay, now let us draw our triangle and let's just substitute what has been given to us. Alright, so this is going to be a triangle and I'm going to name it as A, B and C. Alright, so angle B, I'm going to get it as 90 degrees. I draw the diagram like that, and then we have to choose our theta. So same, here I'm going to choose angle C as my theta. Alright, you can choose it as angle A also. So what is the adjacent side to this angle C or angle theta? So the adjacent side is going to be BC. So this is BC, which is 7. And then what is the opposite side? So opposite side to angle C is AB. So the opposite side is 8. Alright, so we have got two sides, and then we have to find the side AC. Then we'll be able to use our trigonometric ratios and find and evaluate the first bit and our second bit. Alright, so how to find the side AC? We're going to use a Pythagoras theorem. So what does Pythagoras theorem say? It says that AB square plus BC square is equal to AC square. Right. So what is the value of AB in here? It's 8. So it's going to be 8 square. And what is BC? It's 7. So 7 square is equal to AC square. So 8 square is 64 and 7 square is 49. So 64 plus 49 will be equal to the AC square. So 64 plus 49 is simple math, which is just 113. So 113 is equal to AC square, and then AC will be equal to root 113. So root 113, can we simplify it? No, we cannot. It's a prime number. So this is that we can do. We cannot simplify it more further. So let's just write what has been given to us. What we got after solving, so it's going to be the length of AC, which is 113. It is root 113. So we have written it as root 113. Alright, so as we have got our values all the three sides, then we'll be able to find sine theta and cos theta and cot theta. Nothing else to find, because in first bit we have been given to find sine theta and cos theta, and second bit we have been given to ask and find out cot theta. So first of all, let's solve our first bit. So I'm going to mark it as number 1, and we have to find sine theta and cos theta first. So sine theta is, the code is SOH. So sine theta is equal to the opposite side by the hypotenuse. So what is the opposite side here? It's AB. So 8. And the hypotenuse is root 113. So let's just substitute that. Alright. And then we have to also find cos theta. So let's write that. Cos theta will be equal to the adjacent side by the hypotenuse. The code is CAH. So cos theta is adjacent side. What is the adjacent side to angle C or angle theta? It is 7. So it is going to be 7 by root 113. Alright. So we have got our values of sin theta and cos theta now. Let's just substitute them in the thing that has been given to us in the question. So they said us to find 1 by sin theta. So it's going to be 1 by 8 of root 113. I'm going to put the bracket here. And we should also find 1 minus sin theta. So it's going to be 1 minus 8 root 113. And what do we have in the denominator? We have 1 plus cos theta. So it's going to be 1 plus 7 by root 113. Right, and then we have 1 minus 7 root 113. Okay, now if we simplify this, then we'll be able to do our problem. So let's just simplify it now. So this is actually in the form of a plus b into a minus b. So if you remember, we can write it and use that formula in here. So a plus b into a minus b. So what is it going to become? It's going to become a square minus b square. So let's use that formula in here. We can use it in both the numerator and the denominator. So a would be 1 and the b would be 8 root 113 in the numerator. So it's going to be 1 square minus. So let us use that formula and let's try to solve it. So it's going to become 1 square minus 8 root of 113 whole square. Same to do in the denominator. So it's going to become 1 square minus 7 root of 113 whole square. Alright. So let's try to simplify it. So it's going to become 1 minus 8 square is 64, sorry, and 113 root of 113 whole square is just 113 itself. So that is it. And in the denominator, 1 square is 1 and 7 square is 49, and then root of 113 is 113. So that is what we have to do. And then in the next step, let's actually take the LCM both on numerator and the denominator. So it's going to become 113 as the LCM we took it, and on the top it's going to become 113 because 113 into 1 is just going to be 1. So 113 minus 64. Alright, and then in the denominator 2 it's going to be 113 as LCM. So 113 minus 49. That's it. So we can still simplify it. So 113 minus 64, simple math again, just 49. So 49 by 113 divided by, again we have 113 minus 49. So it's going to be 64 by 113. Okay. So we got the fraction as 49 by 113 divided by 64 by 113. So we can further simplify it and we can write it as 49 by 113. We have taken this 113 and we can take the reciprocal and make it as multiplication. We can actually divide it. So we are going to write it as 113 by 64. What we are doing is that we are just dividing it. Okay. So 113 and 113 gets cancelled. And our final answer that we got is 49 by 64. That is it. We cannot simplify it further. So this is the answer that we got for our first bit. Alright. So that was the first bit. We could solve the first bit. Now let us look at the second bit. So in this second bit, we have to find the value of cot square theta. So what is cot square theta? What is the value of cot square theta? This is the reciprocal of tan theta. So the code for tan theta is TOA, which is tan theta is equal to the opposite side by the adjacent side. So as it is the reciprocal, so cot theta will be equal to the adjacent side divided by the opposite side. So it is actually cot square theta. So let's write it as cot square theta. So what is the adjacent side that we have here? So for theta, the adjacent side is 7. First of all, let's write it as BC. Let us write this side without actually writing the value. And then what is the opposite side for this? So the opposite side is AB. So this is going to be whole square because they asked the value of cot square theta and not just cot theta. So BC value is 7. So 7 and AB value is 8. So it's going to be 7 by 8 whole square. So 7 square is 49 and 8 square is 64. So that's it. We couldn't simplify it more. So we are done with the question. We have found out both the values of first bit and second bit, and both turned out to be the same answer. Great. So let's just have a look at this question that we have here. So in here we have been given that if 3 cot A is equal to 4, then we have to check whether 1 minus tan square A divided by 1 plus tan square A will be equal to cos square A minus sin square A or not. Okay, so first of all, we have been given that 3 cot A is equal to 4. This is simple. It looks complicated, but it is just simple. We have just been given one of the ratio and we have to find the others. We have did these types of problems before also. We have to just find out the different values, the different trigonometric ratios, and then substitute these values in this big scary equations, and then we are going to get it. So first of all, they have given that 3 cot A is equal to 4, right? 3 cot A is equal to 4. So cot A from this is going to be equal to 4 by 3. Okay, so we have seen what is the reason for being that. We have taken this 3 from the left hand side to the right hand side, so it was multiplying, so it's getting divided now. So cot A is equal to 4 by 3. So you know that the reciprocal of cot A is tan A. So what is the code for tan A? Code for tan A is TOA, which is tan theta is equal to the opposite side by the adjacent side. So as cot theta or cot A is the reciprocal of tan A, so we can say that this cot A will be equal to the adjacent side by the opposite side. So 4 in here would become the adjacent side. I'm going to write it as AS, and 3 would be the opposite side. So I'm going to write it as OS. I'm going to write it as OS. Okay, and then let's draw a triangle and let's substitute the values that we have got right now. So this is going to be my triangle, and I'm going to name it as ABC as usual. And then this angle would be equal to 90 degrees, so just square over there. And this is our cot A, the angle A, and they are set to use according to angle A. So the 3 cot A is according to angle A, so angle A. So what is the opposite side to angle A? It's 3, and which is BC, the length is BC. So BC's length would be 3 because opposite side is 3. And then what is the adjacent side? For A, it could be AC and AB, as AC is the hypotenuse, AB would be the adjacent side, and we have known the value of the adjacent side from cot A, just 4, so the adjacent side is 4. Now we can find the other side, which is AC, using our Pythagoras theorem. So let's do it. Alright, so what does Pythagoras theorem say? It says that AB square plus BC square is equal to AC square or CA square anyway. So what is the length of AB? It's 4. So it's going to be 4 square plus a BC square, it's 3 square, and which is equal to AC square. Alright, so 4 square is 16 and 3 square is 9, so it's going to be AC square, and then 16 plus 9, simple math, it's going to be 25. 25 will be equal to AC square, and if you want to get the value of AC, it's going to be AC is equal to root 25, and the value of AC will become 5. So we have got the value of hypotenuse, which is 5. So without delay, let's just substitute it. in our triangle. Just update a triangle. So yeah, done. Now in the question we have to find tan square a. This equation, in this equation we get to find this tan square a and cos square a minus sin square a. So if we just find those values, it's enough not to find all the trigonometric ratios. So first of all, let's find the value of tan square a. So you know the value of tan a, the code of tan a, just TOA, tan theta is equal to the opposite side by the adjacent side. So it's square, so it's going to be square also. So tan square a will be equal to, what is the opposite side to this? Angle A opposite is a BC, which is 3. So it's going to be 3 by, what is the adjacent side? It is AB, which is 4. So 3 by 4 whole square, which is going to be 9 by 16. So this is the value of tan square a. Now we have to find cos square a and sin square a. First of all, let's find cos square a. So what is the code for cos square? It is COA, which means that cos theta is equal to the adjacent side by the hypotenuse. The code is CAH. So cos square a will be equal to, what is the adjacent side? It's AB, so it's going to become 4 by, and what is hypotenuse? It's 5, so it's going to become 4 by 5 whole square, which is equal to 16 by 25. Let's just find sin square a also. It's going to become easy to finally solve it. That's the reason we are doing it right now. So then sin square a, the code is SOH, so which is sin theta is equal to the opposite side of the hypotenuse. So the opposite side is BC, so it's going to come 3 and 5 is the hypotenuse, so 3 by 5 whole square, so it's become 9 by 25. Alright, so we have got all the three values. Now first of all, they said that we have to check for 1 minus tan square a. So 1 minus, we have got the value of tan square a as 9 by 16. So 1 minus 9 by 16 divided by 1 plus 9 by 16. Okay, this is going to be our LHS. Let's just simplify our LHS first. First, let's take the LCM of the LHS. First, for the numerator, so it's going to become 16 minus 9 by 16 divided by 16 plus 9 by 16. Alright, so 16 minus 9 is just 7, so it's become 7 by 16, and I'm just dividing this 2 in the same step, so it's going to become 16, and 16 plus 9 is nothing but 25. So this 16 and this 16 gets cancelled, and it's going to be 7 by 25. So this is our LHS, and let's see what do we get if we simplify our RHS. So in the RHS, we had to find cos square a minus sin square a, and we have got the values of cos square a and sin square a as 16 by 25 and 9 by 25. So let us just substitute the values. So it's going to become 16 by 25 minus 9 by 25, which is nothing but 7 by 25. So that was our LHS, right? So 7 by 25 was our LHS. So LHS is equal to our RHS. So they asked whether they are equal or not. So therefore they are equal. So we can say that they are equal. We completely proved them. At last we got 7 by 25 at last. So in the beginning it looked a little tough, but at last we could do it. That is it to do with this question. This is the question number 9 in exercise 8.1. So let us just have a look at it. So we have been given that in triangle ABC, right angle at B, so they have given us the value of tan A is equal to 1 by root 3. We have to find the values of first bit sin A cos C plus cos A sin C, and the second bit cos A cos C minus sin A sin C. So this is also similar to the previous problem. We have been given one trigonometric ratio. So in here we have been given tan A as 1 by root 3, and we have to find the other values, other trigonometric ratios itself, and then we will be able to solve it. That's it. So first of all, let's just write what has been given to us, which trigonometric ratio has been given to us. Tan A is equal to 1 by root 3. So we know what is the code for tan A, which is TOA. So tan theta is equal to the opposite side by the adjacent side. So 1 is our opposite side and root 3 is our adjacent side. So I wrote opposite side as OP. Actually, I write it as OS. I don't know why I've written as OP here. So just consider 1 as opposite side and root 3 will be our adjacent side. So let us draw a triangle in here in order to make everything clear. So this is going to be my triangle and this is my right angle there. And they said that it's right angle at B. First of all, let's put B at the right angle, A here, and then C. Alright, so then it is according to angle A. We should take everything according to angle A. For the first bit, it's tan theta is equal to 1 by 3. So what is the opposite side according to angle A? It's BC. So the side BC is opposite to angle A, so it is 1. The measure will be 1. And then for the adjacent side, it's going to be AB. So AB length would be root 3. Alright. Now again, if we find the other side, which is AC, then we'll be able to solve the problem. So here also we'll be using the Pythagoras theorem to actually find it. So what do we know according to our Pythagoras theorem? So we can write Pythagoras theorem as AB square plus BC square is equal to AC square. Right, so what is the value of AB in here? It's root 3, so it's going to become root 3 whole square. And what is BC? It's 1, so it's going to become 1 square. It will be equal to AC square. Alright, so root 3 whole square is 3 and 1 square is 1, so 3 plus 1 will be AC square. And then AC value would be root 4. So I've skipped one of the steps that I am doing before. So you should be skipping steps as you'll be doing much more problems because it's going to be super easy. But make sure to write all the steps in your examination in order to get marks. But if you want to do it more faster in competitive exams such as that, so we can use this type of tricks. So like 3 plus 1 is 4 and we have directly moved the square also in the same step to the other hand side, so it's going to become super easy now. So AC is going to be root 4, so then AC will be 2. That's it. So AC is 2. We could skip one step and we actually saved more time. Alright, we have also updated a triangle by getting the side AC. Now let's do the first bit, and then we have to find the sine A and cos C, and then we have to also find cos A and sine C. So what is the code for sine A? It is SOH, which means that sine A is equal to the opposite side by hypotenuse. So for A, what is the opposite side? It's BC. So sine A will be equal to the opposite side 1. And what is the other thing? It is hypotenuse. Denominator is hypotenuse. So it's going to become 1 by 2. And then we have to find the value of cos C. What is the value of cos C? So we have to consider the other angle now. So we have to consider this angle. So you know the code for cos. So cos theta will be equal to the adjacent side by the hypotenuse. The code is CAH. So what is the adjacent side for C? It's 1 again. And the hypotenuse wouldn't change. So it's going to be same as 2. And then we have to find the value of cos A. So cos A same. Cos theta is equal to the adjacent side by hypotenuse. So what is the adjacent side for A? It's root 3. And the hypotenuse same. And then we have to find the value of sine C. So sine C will be equal to, sine theta is the opposite side by the hypotenuse. So what is opposite to angle C? It's AB. So it's going to become root 3, the hypotenuse same, so root 3 by 2. So we have got all these values, now just substituting it. So first of all, sine A plus cos into cos C, right? So 1 by 2 into what is cos C? We have got it as 1 by 2 itself. And then what is cos A? It is root 3 by 2. into root 3 by 2 itself. Alright, so we can further simplify this. So it's going to become 1 by 4. 2 into 2 is 4, so 1 by 4. And root 3 into root 3 we can write it as root 3 whole square. It's going to become 3, and 2 into 2 is 4. So the denominator is same, so it's going to become 4 by 4, or you can simply write it as 1. So first bit we have got the answer as 1. So let us solve our second bit. So second bit we have to find cos A into cos C minus sin A sin C. So cos A value we have already found it before. It has root 3 by 2. So it's going to become root 3 by 2 into, and cos C value also we have found it before as 1 by 2, and then minus sin A. So what is the value of sin A? 1 by 2, and then sin C, it's root 3 by 2. So if we further simplify it, it's going to become root 3 by 4 minus root 3 by 4. So just they both are same, so if you subtract same things, you're going to get 0. So first bit we have got the value as 1, so the answer is 1. The second bit we have got the value of 0. So that's it. Cool. So this is a question number 10 in exercise 8.1. Let us just read this question. So in triangle PQR, right angle at Q, PR plus QR is equal to 25 centimeters, and we have been also given that PQ is equal to 5 centimeters. So we have to determine the values of sin P, cos P and tan P. So in this question also we have to find the trigonometric ratios, but actually in the other questions we have been given two sides, or we have been given a single trigonometric ratios from which we are going to get two sides, and then we use Pythagoras theorem and did. But in here we couldn't do that, we can't do that, because we are just given the sum of two sides just 25 centimeters and just one side else. So this is gonna be a little different from the other questions we have solved, so I recommend you to watch it carefully. So first of all, let's write what are the two values, the important values that has been given to us. So we have been given that PR plus PQ is equal to 25 centimeters. It's not PQ, sorry, it's QR. So it is 25 centimeters. And then PQ is equal to 5 centimeters. Alright, so only this we have known from the question. And then let us actually first draw our triangle, and let's just see, are we going to find out something by looking at the triangle. So I'm going to draw my triangle and I'm going to name it ABC. Hey, no, I cannot name it ABC because in the question they said it to take a triangle PQR. So I'm going to name my triangle PQR. So this is my right angle over here. And then we have known the value of PQ, 5 as 5. So this is 5 over here for me. Alright, and then we have been given the sum of two sides. So in the previous problem, we could actually do that. We were given one more side. So then we could actually use our Pythagoras theorem and then we could do. But what can we do over here? Oh wait, what did I just say? I spoke about Pythagoras theorem. Oh, can we use Pythagoras theorem over here also? I don't think so. Okay, but let's just try. So if we want to actually write it in the form of Pythagoras theorem, we can write it as PQ square plus the QR square is equal to the PR square, which is our hypotenuse. Alright, so we have just written our Pythagoras theorem, nothing else. And then what is PQ? So we have known the value of PQ, so I'm writing it, just substituting it, so it's become 5 square plus QR square is equal to PR square. So let's just simplify till the last step that we can do and then think what else can we do. So it's going to become 25 plus QR square will be equal to PR square. No change there. Okay, now we could simplify it more further if we try to do something very sneaky. So in the question we have been given that PQ plus QR is equal to 25. So in order to actually find out the value of PR, what can you do? So if we take this QR from the left hand side, which is on the left hand side to the right hand side, it's going to become PR is equal to 25 centimeters minus QR, isn't it? We can write it in that form. Nothing wrong, right? We just moved it from left hand side to the right hand side. Okay, so in our Pythagoras theorem also, let's just substitute it and see what happens. So we have got 25 already, so let's just continue from here. So it's going to become 25 plus QR square is equal to PR square. We have got the value of PR, so let's just substitute it in form of that. So it's going to become 25 minus QR square. So if you observe, it is in the form of a plus b whole square. So let's just solve it separately. No, it's there in the form of a minus b whole square. So let's just solve it separately and see. So you know that a minus b whole square is equal to a square plus b square minus 2ab. So it's going to become 25 whole square plus QR square minus 2 into 25 into QR. So that's it. So we'll just try to simplify to a 25 square is 625, and then it's QR square minus 25 into 2, we can write it as 50, so it's going to come minus 50 QR. Alright, so now we'll just write it over here. So it's going to become 25 plus QR square will be equal to 625 plus QR square minus 50 QR. So now look at this. Now if you look at this, are you able to see something and are you able to tell that we can cancel out something? Oh yes, we can cancel out this plus QR square and plus QR square in the two left hand side and the right hand side. You could actually take one of the QR square from the left hand side to the right hand side, or the right hand side to the left hand side. It would just become QR square minus QR square. So beforehand, without doing that step only, we just cancel out. So it is going to become 25 is equal to 625 minus 50 QR. Alright. So I want all the alphabets on one side and all the numbers on one side. Two members of the family should be in their own family. They shouldn't come together. So I'm taking all the family members of numbers to one side and all the alphabets to the other side. So it's going to become 25. I'm taking this 625, which is on the right hand side to the left hand side. So it was actually plus. So if I take it to there, it's going to become minus. It's going to become 25 minus 625. And why did I write divided by? Because this is minus 50 QR. This 50 is multiplying with QR. If you take it from right hand side to the left hand side, it's going to become divided by. It's dividing right now. So this will be equal to minus QR. Alright. So we can actually further simplify it. Let's do that. Then we'll be able to get the QR, I guess. So let's do. So 25 minus 625 will be minus 600. So minus 600 by 50 will be equal to minus QR. Okay, so I cancel this 0 and 0 over here, and 5 ones are, and at what place that 60 comes in 5 table? It's 12. So we can say that minus 12 is equal to minus QR. So I'll also cancel this minus on both sides. I can do it, right? So QR length would be equal to 12 centimeters from here. Oh yeah, we have got the value of QR as 12 centimeters. If we get one value in the triangle, then we could find out the other, and we could find out all the trigonometric ratios. So GG, we got one of them, so we could do the other now very easily. Let's update a triangle now. So this QR is going to be 12. Now we have to just find the other angle, which is PR. Then we could get it very easily. We could find all the trigonometric ratios. So let's do that now. From now it will be very simple. First let's use a Pythagoras theorem. So it's going to be PQ square plus DQR square will be equal to PR square. So what is PQ? We have got it as 5. So 5 square, and then QR length, it's 12, will be equal to PR square. So 5 square is 25. 12 square is 144, it's PR square, and then 25 plus 144 is 169, so it is PR square. So if you want to get the value of PR, it's going to become PR is equal to root of 169 and then PI will come out to be 13 centimeters. So we have got 13 centimeters. Let's just substitute and update our triangle. So yeah, it's done. Now we have to find the values of sine P, cos P and tan P. So let's do that. So this is our angle P. So according to that we should be doing. So then what is sine? Sine theta is equal to the opposite side by the hypotenuse. You should be knowing it by now because we are doing so many problems on that. If you want the code is SOH. So sine P, let's write it. So what is the opposite side? It's QR. So it's going to be 12. And what is the hypotenuse? It's 13. And then cos P. So cos theta will be the adjacent side by the hypotenuse. So if you want to remember by code, it's CAH. So what is the adjacent side? It's 5. It is PQ and hypotenuse is 13. And then tan P will be equal to the code is TOA. So opposite side by hypotenuse. Tan theta is equal to the opposite side by hypotenuse. Sorry, the opposite side by the adjacent side. So what is the opposite side? It's QR. So it's going to become 12 by 5. So yeah, we have found all the values that has been asked. Sin P, cos P and tan P. So we are done with the question. So let us have a look at this question number 11 in exercise 8.1. So first of all, in here also let's draw a diagram, a triangle, so that it's going to be easy to visualize everything. So this is going to be my diagram. So this is going to be 90 degrees. So I'm going to name it as A, B and C. So let us see what is the first question that has been given to us. So in here the value of tan A is always less than 1. So is it true or false? And we have to also justify our answer. So you could simply say this statement is false. You can simply actually take an example also. If you just take a triangle ABC with one side as 3, one side as 4 and one side as 5. What is tan theta? It is the opposite side by the adjacent side. So if you actually see, so if I take this as 3, this as 4 and this as 5. Now if you actually try to do, so what is gonna be the tan theta? So if I take this as theta, so what will be the value of tan theta? It will be 3 by 4. In this particular situation, it is less than 1. But if you actually switch this, and actually if you put 6 over here, and if you put, no, let's actually take 5 over here and let's just switch these 4 and 3. So now it's going to be 4 by 3. So now what is tan? It is greater than 1. So some situation depends on situation, but always it cannot be less than 1. So this statement is false. The justification is in some situation it can be less than 1 but not in all. And then let's look at the second one. So sec A is equal to 12 by 4 for some value of angle A. So this statement would actually be true. By looking at itself, this also you can say it's true. And again, like this previous question, you actually take a triangle and you could try, and then you could get 12 by 5 as one of the answer. Alright, so that is the reason we are going to get it. We can say that it's true. So number 3 is cos A is the abbreviation used for the cosecant of angle A. It's 100% false because cos A is the abbreviation would be, the abbreviation of cos is actually cosine and not cosecant. Okay, so we are done with the question. It's false. So number 4, cot A is the product of cot and A. It's again false. So A is the angle that is being used after cot. They are not being multiplied. It's just the angle. So you cannot actually multiply them and differentiate them. Alright. And then the last question. So sine theta is equal to 4 by 3 for some angle. So this is going to be false as well. So if you remember in the first video itself, I have said that hypotenuse is always the greatest side in every triangle. But in here, actually the hypotenuse is 3. Why? Sine theta is equal to the opposite side by the hypotenuse. So the opposite side is 4 and the hypotenuse is 3 here. So it cannot be 3 because 4 is greater than 3. It is one of the side. But actually hypotenuse should be the greatest side, but it's not. So that's it. We have completed all the questions in this exercise 8.1. I hope you have understood, and this takes a lot of effort, and I hope you would like this video and subscribe for more content like this. let's move on and let's see what topics we are going to get more in this chapter trigonometry. Make sure to subscribe.